Okay, now
So
yeah.
yeah,
Yeah.
this is the front side. This is the back side of an say metamaterial unit cell.
Okay, okay.
Okay, so if we could just see the response of it, so it is coming in like this.
Okay, okay, great, great. So the thing is,
Yeah.
it is, you are designing for 45 gigahertz, 44 gigahertz, something like that.
Yeah, I was trying to design it for 43 to 47, but it is coming at 45.
Yeah, 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 yeah. Great, great. So,
Yeah,
so
just
the
I
thing is,
just so
yeah,
my question
please.
is, how do we analyze this phase reflection? How do we analyze this?
See, can you open your CST file and then show me so that I will tell you how to
Sure.
analyze it. See, in do you have amplitude plot for this? Amplitude plot for this? Amplitude plot for this? See, the thing
Amplitude.
is,
No. Okay.
no, no, right? So S1 on amplitude and phase you have, right? Ah, this is the one. This is the one I want. Okay. So can you zoom
Yeah.
a bit? Let me tell you. The thing is, here you can see. So amplitude wherever you are getting resonance, right? Resonance. Okay.
Uh-huh.
So this is the resonance, right? Similarly, you can find that there will be a zero crossing, a similar place you might have seen. Correct. So there is a zero
Oh,
crossing, right? Yeah. So
yeah.
that is the resonance in the phase. In the phase, if you see that, I think around -5, that is same place. If you correlate both the curves in the same
Yeah.
time, there is a, you see, there is, if there is a zero crossing, that means, resonance is happening. Okay.
Okay.
Okay, so because it's a kind of LC tank circuit, right? So for example,
Mhm.
means there is exchange of energy between L and C, right? So if you're
Mhm.
having below zero, then it is actually inductive, I think, capacitive. Then above zero it is inductive, right? So there is a transfer is happening. That's why the resonance is happening in this place, particular place, 17 or
Okay.
something like that. Yeah, similarly you can bring down and scroll down, and then near 17 only you might have got this resonance as well, correct? Yeah.
Okay.
So this is the one inference we are getting there.
Okay. Okay. So one question I have. So how do we first calculate the unit cell dimension? If I could just share you one of your papers only.
Yeah, yeah,
Yeah, this one.
yeah, yeah, yeah. So
So here you have.
unit cell dimension is in general it is lambda by 2 in general.
Okay.
Okay. You can take, for starting purpose, you can take lambda by 2. You can even analyze the lambda by 4 as well. Okay. So, but that is, depends. See, the thing is, the unit cell size depends on, many parameters, right? So one is,
Mhm.
how much phase range, phase dynamic. See, phase curve, if you take phase curve, right, you have
Okay.
many parameters, right? One is
Mm.
the can you go back? Can you scroll down this paper? I will tell you. You have to see. Ah, yeah, yeah, this one. So this one, no, unwrapped phase. Okay, these phase curves, right? Unwrapped
Mhm.
phase. Unwrapped phase means, so what you will do whenever there is a zero crossing happening, right? I will subtract that with the minus 360, so that it will get unwrapped. And then, you are getting, for example, by 500 degree, right, minus 600 degree, something like that, right? Correct.
Yeah.
Yeah, on the left. Okay, so which means, see, in the phase curve, no, you have to infer many things. One is how much phase range you are covering, okay, with a particular
Okay.
unit cell. That also depends upon the unit cell size. If you are having
Mhm.
small unit cell, no, then will not able to achieve dynamic range. This we call it as dynamic phase range. 600 degree you have, right? So that is
Okay.
actually a dynamic phase range. So if you are having small unit cell, right, you will not be able to achieve. But at the same time, see, anything can be complemented, right? For example, with the help of structures. Actually, what we
Mhm.
are doing with the size of the structure and also the substrate and ground plane and the patch structure, so all are complementing each other to generate, for example, some particular response, right? So
Okay.
with the for example, some structure, no, may give even with the small unit cell size also, you can able to achieve large dynamic range. That also possible. Okay,
Okay.
so that is a structure dependent. Okay, okay, that's the only thing. Okay.
Okay. So I just want to know, sir, this lambda by 2.
Yeah, yeah, lambda by 2 you can take.
Lambda is in terms of C by F, right?
Yeah, yeah, C by F. C by F, in general, lambda 0 may be shifting here and there, because actually it should be lambda G. Lambda G is nothing but your epsilon naught divided by square, sorry, um, dielectric constant divided by square root of Actually, the actually lambda g is nothing but your lambda by square root of epsilon r. Okay, so square root of
Okay.
epsilon r is your substrate wavelength. So lambda naught is for free space wavelength, right? So when you want to calculate the resonant frequency for the particular unit cell that has substrate non ideal case, non air conducting medium, then the lambda will be changed, right? So therefore,
Okay.
even if, but you can take it zero point 0.5 lambda naught itself, so free space wavelength, but you may get some shift here and there. That's okay,
Oh,
no problem. Yeah.
okay. So if I if so one more is there. So
Hmm.
in this thing, we don't consider this. If I want to make complete reflective meta
Okay.
surface, so
Okay.
S11 we don't consider, because if we
No, no,
consider
no,
it,
no, yes, no, no,
yeah,
amplitude you are saying, amplitude you are
yeah,
saying.
this one.
No, 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 no. We should consider. See, why I'm saying is amplitude. This amplitude plot will dictate you that how much loss is happening in that particular zero point 0.3 dB is there. Okay, then it's fine.
Okay,
But if it is going beyond 1 dB, then it will become a trouble. Okay. Chali.
okay, okay,
So this curve, no, this curve, whatever you are seeing, right? So that is, you are having kind of V shape, right? This should be kind of a wider bandwidth. So therefore, when you are having wider bandwidth, your phase curve will become smooth. So you can complement. See, you can able to find out the bandwidth from the either from the this amplitude curve or also the phase curve as well. Phase curve. See,
okay.
whenever your element is wider bandwidth, right? That time you will
Uh-huh.
have a sharp means a smooth curve will be there. Okay, smooth
Okay.
face curves will be there. But
So
whenever you
for
are,
if
yeah,
this one, it will be like this then.
yeah.
Okay.
So this one is unwrapped face. If you go to CST, I will tell you how to unwrap that face. That also I can
Yeah,
tell you.
yeah.
No. So for only for frequency versus phase, you can do the unwrap. But for the this one, right? So loop length versus phase, that you have to unwrap manually. That's it from in
Yeah,
the Excel sheet.
correct. Correct. Yeah, one more thing is it, like here you have given see loop length versus this reflection degrees, but I'm not
Right.
able to plot this thing.
I say that is in post processing you have to plot it. Okay.
Okay, but
Okay.
how
I
can
will
I
tell.
optimize it first? But I need to first optimize it, right?
That's fine. See, once you get the frequency frequency versus reflection phase, loop length versus reference phase, both are one and the same. Okay, the notation
Okay,
is different. That's it. Okay, so frequency versus phase, which means see, element length is see each frequency corresponds to some part of the length element, right? Correct.
okay,
So
correct.
element lambda is nothing but a frequency, right? So whenever
Hmm.
you change the loop length, you are going to get the variation in the phase, as well as when you are going to change the frequency for a particular wavelength. If you are going to change the frequency, then again you are going to have the different phases, right? So that both
Okay,
are. If you want to plot, no, let me tell you, go to post processing. I think in that one of my video, it is clearly I plotted for one value also. Post
okay.
processing, and then result
Expose this
template.
data.
No, 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 no. This is for
Okay,
exporting. Result
okay,
template, result
okay,
template. Then you will have first select template group, general 1D. Then yeah, 1D or 0D, 0D or 1D. Yeah, here. Wait. It will come. Mean value is there, right? Y at given
yeah,
x. Give y at given x. Y at given x. So
okay.
what it does is,
Why we are selecting y and given x here
yeah,
only?
let me tell you. See, the thing is,
Okay,
y means what we are considering is reflection phase. Okay.
okay.
Whatever parameter you are selecting on the bottom, you can see here on the bottom there is a list, right? On
Yeah,
the
yeah.
bottom. Yeah, y at a given x means for a given frequency x is nothing but you can put some frequency, for example, 17 gigahertz or anything. Okay.
Okay.
So for
Okay. Let me pull.
x frequency, whatever parameter I am changing, for example, loop length as the parametric sweep or whatever it may
Okay.
be. For that, what it does is for x frequency, what is the value I'm getting? For example, when I change a loop length from 1 to 2, what is the variation? 1 at 1,
Oh,
what is the value? 2, what is the value? 3, what is the value? 4, what is the value? 5, what is the
okay.
value? Like that, it will start plotting for only for
Okay.
this
Yeah.
frequency.
Correct. Yeah, this thing
Yeah.
I wanted to have. Okay.
yeah
Then.
yeah and also where pick this value, it will pick from the frequency versus phase curve only. It will pick the value
Okay.
from frequency versus phase curve. What it will do is it will monitor the here on the bottom you can see S parameter is Z max 1 is there, right?
Yeah.
Yeah, this is actually S11. Okay.
Yeah.
Okay, here you are, what do you want to plot? You want to plot magnitude, magnitude dB or phase.
Yeah. We want to plot phase. Hello.
Oh, sorry.
Yeah.
Yeah. Here on the yeah phase you can select. Okay. Yeah. Okay.
Okay.
If you give okay. Now next time whenever you do parametric sweep of the any length of the patch, then it will get
Uh-huh.
plotted on the bottom. You can see on the bottom. You can see. Can
Okay.
you put evaluate all? Now it will not generate. Evaluate all. Evaluate all. No. Evaluate all. Yeah.
Okay.
Can you close this window? So on the bottom, on the left navigation tree, you can go to the bottom. Yeah, tables is there, right? Tables, 0D results. Okay, on the bottom. Yeah, this is the one. But now it is calculated for only one value, loop length. Next time when you start plotting that, it will automatically get plotted. Okay,
Okay.
okay, great.
Okay. Then
So then now
this is my this side what it
phase,
will be.
phase. It will
This
come.
is
It will change, get changed. No problem. Don't
okay.
worry.
Okay. The thing is, it will come like this now, right?
Exactly. Not like this. It will be a kind of Can you go back to CST file? Yeah, on the this one. And can you go click on that? It will be like this only. You have to unwrap it. That's it. Okay.
Okay.
How to unwrap now? I have put in one video in detail. Okay, how to unwrap the face and all. You can just
Okay.
go through it.
Yeah.
Here,
That will be good if you could share me that link also.
I think in the same link, same group only, CST videos, something like that is there, right?
Okay.
In that same group only, there's videos. That's why I grouped. Some many people ask that. So where is that video? So if you want, I can just find out and share it with you. No problem.
Yeah. Yeah. Yeah.
In the description also, I might have given. So what is done in that particular pattern? Okay. Here,
Okay.
can right click it. Here, can you right click it? Yeah. I don't know on the plot, on the plot, on the plot, on the
Okay.
plot.
Okay.
No, not this. Yeah, right click it. Plot properties. Here, yeah, wrap, phase wrap is the right phase wrap on the no
Mhm.
on the phase wrap. Yeah, can you click at that? Unwrap. Okay, click apply. Yeah. Now
Oh.
can you see?
Yeah.
This is how it will become. That's it.
Yeah. Yeah. Thank you. Thank you. Thank you.
Yeah.
Yeah. So if I analyze this graph only,
Yeah.
so my phase is coming from if I need to
But this is
how
not, I look like, it's not that correct result. But I don't know, maybe structure is like that only. I don't
no
know.
let it be wrong only. I just need to how to analyze it. So it is coming from so if
Hmm.
we make it from zero, right?
Yes. No, not
From
zero. See, the whole operating frequency range, what is the phase I am getting? That's all. See, what you will do while designing meta surface, what you will do, you will see there is a two curves, right? One is phase versus frequency, sorry, phase versus loop length or
yeah.
some geometry length. Okay. The other is location versus phases. What phase to be compensated at each location of the reflective surface or whatever it may be. Okay.
Hmm.
So here, what is common? Phase is common. What is different? Here it is patch dimension. There it is location of the
Okay.
reflector. So you have to map what you will do. Phase is common. For example, you want to compensate the phase at by X location. For example, 45 degree you have to compensate. 45 degree you have to compensate. Okay, at X location. You have
Okay.
to come back here and find out. Not this plot. You have to go to that table plot, right? That on the
Uh-huh.
bottom.
Uh-huh.
There you will have 45 degree against some dimension, right? You have to
Okay.
take that dimension and then place, you design the patch with that dimension and then place it over the X location.
Okay.
That's the only thing.
Okay.
Yeah, it's in little bit tricky, but it's doable, no problem.
Yeah. So
If
one
you
more
whenever
thing
you
I need
find
to
any doubt, no, I think some. I think 2 or 3 videos I discussed there. Some of the people asked me, and
okay.
some
So
no, yeah.
one more thing, Linga. I just need to know how
Hmm.
do we calculate, how do we select this any substrate selection? How do we select it?
See, the thing is, first and foremost thing is for academic, we have to find out whether it is easily available or not. That is the only
Oh,
criteria you have to follow. Second thing
yeah.
is that, if you have what is your bandwidth requirement, that also depends. For example, if you want a narrow bandwidth, cheaper substrate, then you can go for FR4. But you want a broader bandwidth, then what you have to ultimately go for is low dielectric constant substrates. Okay,
Okay.
low dielectric constant substrates, and also the thicker substrates. But at the same time, you will lose the gain as well. So it is a
Okay.
compromise between gain and bandwidth, right? Gain bandwidth product are
Yeah.
constant. So that is why, we have to play with the thickness, but thickness should be standardly available. So it will come in
Yeah, it should be standardly
ounce, right?
available.
Yeah, ounce, right? So 0.035 multiples of 0.035 multiples of, okay,
Okay.
2, 3,
Okay.
5, like that. It will, so multiples of ounce will be there. So that we have to
Yeah.
check, okay, this available or not easily.
Yeah, for
So
this
but that is
meta surface, how much is the gain? Gain should be how much at least?
the gain is solely depend upon the aperture size, right? Gain is aperture
Okay.
size. Okay, so if you can manage to design any structure, okay, that
Mhm.
can offer, with the smallest structure, then that is the best design basically. Okay, so gain,
Okay.
what we are doing? So what we are doing is, see, we are correcting the phase. That is the gain, right? So
Mm-hmm.
radiation patterns are coming out. There is a, phase correction required. So what you are doing with the meta surface, you are correcting the phase, and therefore the gain is getting enhanced. That is what is the we are doing. Okay, so that if you can do it with the aperture, higher aperture size, or for example by playing with the structures, and then you can do it. So both are one and the same. Basically, what you are doing is, see, gain is basically you are nullifying the trying to nullify the LC components. That's the only thing.
Okay.
So purely resistive power additive. So because, resistive means it will dissipate the heat, dissipate the energy, right? But whereas
Okay.
the LNC, it will store the energy. But that doesn't, for antenna, it is not, does not, we do not want the energy to be stored. So it has to
Mhm.
dissipate in a proper direction, right? That is what the meta surface is doing. Yes.
Okay.
Right.
Okay. So in this one, S21 we don't consider.
Yeah, yeah. You see, if it is a, means, for example, it is a reflecting surface, no need to consider, because on the back side you have a ground plane, right? If you do not have a
Okay.
ground plane, and then you have to consider these values.
Okay.
Okay.
Yeah, this is good then. So, is there any option to enhance the beam forming on this meta surface?
Yeah, yeah, definitely. There is, a lot many papers are there. So what you have to do is you have to control the phase. That's it. So means wherever, means, see, it is a kind of we can say phased array, kind of a
Mhm.
phased array. Okay, but the phased array, you are, for example, feeding, direct feeding you are giving here, spatial feed, we can consider it as a spatial feeding. Your patch is radiating, that, you are controlling the radiation pattern in such a way that phase is getting compensated. And we have to approach rate tracing approach, for example. Many theories are there, but it is a kind of a, so what phase, see, the main ultimate thing is you have to get the gain, right? So
Yeah.
if you want to calculate the phase, means phase to be compensated at each location, there is a formula,
Mhm.
right? Parabolic equation formula that I think I have discussed in one of the video. So there you have to decide which direction I ought to project the beam. There, there is a parameter available. Okay, so
Yeah.
and that, with that only we can control this values. See, anyway, ultimately it is going to be the compensating the phase. That's it.
Okay.
Yeah.
Yeah. So I would like to know your mobile number, Linga.
Yeah, I already sent you via mail. Okay.
Okay, you
Yeah.
send me the email.
Yeah, 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 yeah.
Okay. So
WhatsApp number.
this
Yeah,
regarding this phase formula and this video you were saying, if you, I will
yeah,
be highly thankful if you just share me that thing also.
yeah, yeah, yeah. Definitely, I will share. Okay.
Okay.
In that,
So
in that paper
yes.
itself, I have discussed how to find out the phase to be compensated. All that
Yeah,
stuff
yeah,
I have discussed. Okay, you can check.
yeah.
Okay,
And one more
then I.
thing, your this unit cell is there, right?
Yeah, 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 yeah,
So I would be very thankful if you could share me this template because I think this is parametric in it. So I just
yeah.
need to analyze how do we make this thing very parametric and all that.
Okay, okay, yeah, 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 yeah. I will, because I think it might be in my personal. So let me check in, and I'll definitely, I will, share with you.
Yeah,
Okay.
please.
Yeah, yeah, yeah.
Yeah. So that's it from my side. This is very helpful and thankful for you, your cooperation and your time
No
giving.
problem. No problem. No problem. No problem. Okay.
Yeah,
So I let me share that link to you. Okay. Fine. Okay.
yeah.
Okay. So great. And if you need any help, no, please feel free to ping me. Sorry for that yesterday.
No, 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 no,
I will
no. I'm
definitely help
I'm
you.
really thankful. Actually, I was going. I was trying to. Actually, I'm trying to research on this one. So I
Uh,
found very two three videos of you, and I found very
yes.
interesting
Yes.
going on there.
Oh, thanks. So I
Yeah,
have
so I
shared in
thought,
this, this is the group, means there where
okay,
I have shared all the CST related videos. Okay. You can
okay,
just
okay.
find out there. No problem.
And
I
that's
think seven.
that file also CST
Yeah.
file.
CST file I will just, share with you. Definitely. Oh, yeah, I will, because, it might be in my mail. I will definitely share with you. Don't doubt.
Okay,
Okay.
okay, okay.
So, so
Okay,
great.
thank you. And if you need anything from my side, I will be highly obliged. If in
Yeah,
future
no
or
problem. Yeah,
yeah,
yeah, definitely, definitely.
please
So
do
be in
remember
touch.
me, and I will
Yeah, yeah,
be always
definitely,
helpful.
definitely. So I love to, hear that, So yeah, all the best and God bless you. So definitely,
Yeah,
I will definitely give you support to the best extent possible. No problem. Okay.
yeah. Thank you, thank you, thank
Okay.
you.
Okay. So take care, and then we'll see.
Yeah,
Catch up.
you also take care and
Yeah, yeah,
stay happy, sir.
yeah, yeah, yeah. Definitely. I always stay happy. So with your
Yeah, stay
blessings,
happy and safe.
yeah, yeah, no problem. Okay.
Okay,
Thank you, Ji. Bye,
okay, bye.
bye. Great, great. Bye.